Hello and welcome to part 4 of the 1960s Japanese-made Univox U45B guitar amplifier project. In this part 4 video, we're taking a look at a couple Univox U45B schematics. When I first got the amp that I'm presently working on, I didn't have a schematic for it in my collection of schematics. So I searched online for one, and this schematic is essentially the only U45B schematic/circuit I could find online. I found multiple U45B schematics, but they all contain the same circuit, this one. If there are other U45B schematics online that differ from this schematic, I sure couldn't find one. Anyways, this circuit doesn't completely match the circuit in the U45B amp that I have. So I made up a couple schematics for the U45B amp that I have. One being a more traditional looking schematic, which would be this one. The other showing all the connections to the PCB board and the trace connections on the PCB board, which would be this one. The squares show connections to the PCB board, and the circles show trace connections on the PCB board. So this is the circuit in the U45B amp that I have. There isn't a lot of difference between this schematic and the one that I found online, but there are differences. When I got this amp, it was in pretty rough shape. I trashed what I didn't want to mess with, then cleaned and tested what was left. The transformers, pots, etc. all seem to test good. I guess we'll know for sure when the amp is completed. But long story short, I've never heard this amp/circuit work or play. And the schematics that I made are just to preserve the circuit of the amp as is when I originally got it. Now, whether or not the circuit will remain the same is another story. Let's take a quick look at the U45B schematic that I found online. Besides the differences already pointed out, everything else matches the amp that I have, and I'll be addressing the differences here in a bit. The amp uses a 12AX7 tube that has two triode sections. One triode is used for the first gain stage, and it uses grid leak biasing. The other triode is used in the tremolo/oscillator section. The amp also uses two 6BM8 tubes. Each 6BM8 tube contains a triode and a pentode. One of those triode sections is being used for the second gain stage, and it is cathode biased. It also uses a cathode bypass cap. The other triode section is used for the phase inverter, which is set up as a cathodiene phase inverter. Both pentode sections are being used as output/power tubes, and they use shared cathode biasing and also use a cathode bypass cap. And last but not least, here we have the little but mighty useful 6x4 rectifier tube used to convert AC voltage into DC voltage. Yeah. Anyways, here we have three inputs labeled guitar, accessory, and auxiliary. Each input jack is a switching jack switched to ground. Now, even though the three inputs have three different labels, as far as I can tell, all three inputs are set up the same. If nothing is plugged into the amplifier, we have three 47K resistors in parallel to ground that provide about 16K resistance to ground on the input of the first gain stage. And that helps keep the amp quiet when nothing's plugged into it. If we plug into one of the inputs, we have one 47K input resistor and two 47K resistors in parallel to ground. To me, that looks like we have a voltage divider going on here with 47K at the top and 23.5K at the bottom to ground, and taking the signal at this point. And if I'm correct, that also means the original input signal will be attenuated quite a bit at this point. Now, maybe after the amp is completed and functioning correctly, I can pull out the signal generator and the oscilloscope to verify the attenuation at this point compared to the original input signal. See what happens. Now, if we plug into any two of the inputs, we'll have two 47K input resistors and one 47K to ground. So plugging into any two of the input jacks will pretty much be the same. And if we plug into all three inputs, long story short, as far as I can tell, even though the three inputs are labeled differently, all three inputs are set up the same. And the only real difference will be the input/loads plugged into the amp, which that can make a difference. The single knob tone control here is essentially an adjustable high pass to ground that dumps more or less of your highs to ground based on the position of the tone control pot. This is your volume control pot, and it adjusts the volume of your amp. The output transformer shows 16K on the primary side for the output/power tubes, and 8 ohm on the secondary side for the speaker load. This is the tremolo oscillator section with a tremolo speed control pot and a standard type non-switching foot switch jack. The tremolo oscillation tickles the grids/bias of the two output tubes to provide the tremolo effect. Oh, and here's the to die for capacitor. So that about does it for the quick overview. Next, let's take a look at the differences between the amp circuit in this U45B schematic compared to the amp circuit in the U45B amp that I'm presently working on. One of the differences between this schematic that I found online and the amp that I have is this schematic doesn't show negative feedback, and the amplifier that I have has negative feedback. Here's a schematic of the amplifier that I have, and I've highlighted the negative feedback in yellow. Now, I imagine those of you familiar with negative feedback are looking at this and thinking to yourselves, it looks a little strange. However, this is how the negative feedback was implemented in the amplifier that I have when I received it. But with the negative feedback signal being injected into the circuit at this point, just above this tube's cathode resistor and bypass cap, it certainly isn't the more traditional way we're used to seeing negative feedback set up, like in Fender amps, for example. Here is a Fender Princeton AA 964 schematic. And again, I've highlighted the negative feedback in yellow. And we can see that Fender injects the negative feedback signal into the circuit at this point, which is below this tube's cathode resistor and bypass cap. The 47 ohm resistor is used to provide some resistance between the negative feedback signal and ground to encourage the negative feedback signal to play with a circuit rather than dump its signal to ground. Here is another schematic for the amp that I have. It shows the PCB board connections as squares and trace connections on the PCB board as circles. I've also highlighted the negative feedback in yellow. Here's a terminal strip with two resistors. And here's what that looks like. And it doesn't take a lot of imagination to see that they inserted this terminal strip and two resistors between this tube's cathode and its K2 connection. This K2 connection also leads to this tube's cathode resistor and bypass cap. And here's that K2 connection on the PCB board. And originally, this resistor's leg was soldered directly to it. A wire ran from this tube's cathode to this point of the terminal strip between these two resistors, and a wire ran from the tube's output to provide the negative feedback signal to this point on the terminal strip. And this is why I refer to this as an add-on ad hoc negative feedback loop. And again, I don't know if this was tacked on at the factory or if someone tacked it on after they purchased the amp, but I'm bringing it up again in the hopes that maybe somebody will watch this video and know for sure either way and will chime in the comment section below and let us know. So the remaining differences between this schematic and the amplifier that I have are all in the tremolo section. This shows the tremolo from the schematic that I found online and the tremolo that's in the amp that I have. And these two tremolos have two main differences. One being this tremolo uses a standard non-switching jack for the foot switch, and this tremolo uses a switching jack for the foot switch. The second difference is this tremolo has a speed control, but no on-off switch, and this tremolo has a speed control with a built-in on-off switch. To turn this tremolo on, you have to plug something into the foot switch jack so that the tremolo tube's cathode can connect to ground and turn the tremolo on. You can use a shorted quarter-inch plug that will turn the tremolo on all the time and then turn the speed control to 0 to kind of turn it off. Or you can plug in a foot switch jack that will allow you to connect and disconnect the tremolo tube's cathode to ground, turning the tremolo on and off. This tremolo has two main scenarios. One is no foot switch plugged in, and the other is having a foot switch plugged in. This shows the tremolo in my amplifier with no foot switch plugged in. Here, the on-off switch is in the on position and the tremolo is on because the tremolo tube's cathode can reach ground by passing through the on-off switch and passing through the switching jack to ground. Here, the on-off switch is in the off position and the tremolo is off because the tremolo's cathode can't reach ground. When it comes to the on-off switch is open. Therefore, the tremolo tube's cathode can't reach ground and the tremolo is off. So here again, we have the tremolo from the amplifier that I have. This time, we have a foot switch plugged into the foot switch jack, or at least my representation of a foot switch. But before we get to this, we need to understand that in order for the foot switch to turn the tremolo on, the on-off switch cannot be in the off position, because if it's in the off position, the cathode of the tremolo tube can't connect to ground, and the tremolo is going to stay off no matter what the foot switch does. So here we have the on-off switch in the on position, but the tremolo is in the off position, represented by this open switch. And the tremolo is going to be off because the cathode of the tremolo tube can't reach ground. It can pass through the on-off switch and be handed off to the foot switch via the switching jack, but when it gets to the foot switch is open, so the cathode of the tremolo tube can't reach ground and the tremolo is going to be off. Here we have the on-off switch in the on position and the foot switch in the on position, represented by the closed switch. And the tremolo will be on because now the cathode of the tremolo tube can pass through the on-off switch and be handed off to the tremolo switch via the switching jack. And this time it can pass through the switch in the foot switch to ground, and the tremolo will be on. So this video catches me up to where I'm presently at with the amplifier, build-wise, and I can start working on it again. And hopefully here soon I can have a couple more videos showing the completion of the amp and maybe some testing of the amp and perhaps coming back to the attenuation on the input jacks. But until then, this ends part 4 of the 1960s Japanese-made Univox U45B guitar amplifier project. Thanks for watching.